right, so last time we breadboarded our circuit and we played around with some things like modulation and a couple of other features, and we got it sounding pretty nice. So today we're going to take that circuit in all of its glory and we're going to lay out a PCB for it that's going to allow us to box it up into a nice enclosure. Now, before we can start laying out the board at all though, there are a couple of things we need to do. The first thing that we need to do is we need to determine what size of enclosure we're going to put the effect in. That's going to govern the maximum amount of board space that we're going to have to be able to lay our circuit on. I'm going to do a 125B because they're pretty common, they're relatively cheap, and I really like the form factor. The second thing we need to do is we need to determine our control layout. Now, the reason the control layout is so important is that that's the very first thing that we're going to place on our board once we get to the actual layout process. And we could put our controls in a lot of different ways. For example, we could do a pretty standard 3 knobs on the top and then the remaining 2 knobs and 2 switches on a second row. And, that would work perfectly well. We could also do something a little less traditional. I thought I might do something pretty different for this, something different than what I've done, which has usually been a pretty traditional control layout. I've always liked the look of those enclosures where they have like the knobs at a diagonal, or they've got them broken up on, 2 sides of the enclosure or something. And I thought that with a ping pong delay where our delay is bouncing back and forth from side to side, it might be kind of cool to have controls that mimic that, where we have controls for one side on the one side and for the other on the other. And so I think that I'm going to go ahead and do that. I'm going to have 3 knobs down one side, and I'm going to have the 2 switches and 2 knobs going down the other side. And maybe I'll do something with the enclosure art to make it look like something's going back and forth between them or something. After the control layout, we need to figure out where our other bits of hardware that go in the enclosure are going to be. For example, the input and output jacks, the power jack, the LED, and the switch. We need to figure out where those are going to go, whether they're board mounted, whether they're going to be off-board wiring, and just kind of how everything's going to fit inside of that enclosure. Now with the 125B enclosure, there's plenty of depth to the enclosure to be able to put the circuit board in and to top mount the input and output jacks and the DC jack. So that's what I'm going to do. That means we only really have to worry about the foot switch and the LED being somewhere else in the enclosure. And I'm just going to stick with the foot switch being on the center line but down at the bottom of the enclosure. But I thought it might be kind of fun to have the LED placed such that it looks like maybe that's what's bouncing back and forth between the 2 sides. So it'll still be on the center line, but it's not going to be level with any of the controls. It'll actually go kind of on the diagonal between 2 controls to look kind of like it's bouncing back and forth or something. So with all of that defined, now we can start actually laying out our board. All right, so here we've got Eagle. We've got our full schematic here, and we're going to start by clicking on the SCHBRD button up here. This will bring up a board for us, create from schematic, yes. And so now it gives us the outline of what our board could be, but because we're going to be doing a 125B, our first item of business is going to be to make this the right size. And I usually shoot for 2.3 inches in width, which you can see up here. It tells you your X and Y. And then I usually shoot for about 2.5 inches in height. I've just found that that works well. Actually, we're going to go a little more than 2.5 because we are going to have a switch that requires us to go pretty much all the way to the top, which means that our board is actually going to need to be, let's see, I'm actually going to measure this on my drawing for my control layout that I showed earlier, and it looks like I am going to need a board height of about 3.25 inches. So we're going to come up here and we're going to go ahead and make it 3.25 inches. Now the thing to remember is that we're looking at the board flipped, which means that this is going to be the side the input comes in on, the side the output goes out on, and now we're going to start placing our controls. So we're going to take our sync control. I'm going to have this go side to side actually. And I know that I need it 0.75 inches off of my center line. Center is going to be 1.15, and if we take 0.75 off of that, we're left with 0.4, right? So we're going to send this guy over here to 0.4. And we're basically going to put him just about as close to the top as we can get. Oh, wrong side, because my board is flipped. So we want 1.9. Beautiful. And then underneath him is going to go our time 2 control. Here's our time 2 control. And the distance between the center of this switch and the center of the pot is going to be 0.9 inches. So I'm going to need to come in here, and we can see that we've got this at, it says 2.95. If you hold down on Alt, it'll actually show you a finer resolution. That's 2.95. And this is 2.225. So from here, if we're coming down 0.9, we need 2.0. We need this guy at 2.05. So let's move him. And then if we come check, we need to come down 25 thousandths. And because I'm working on a 50 thousandths grid, if I press and hold Alt, I actually get a much finer resolution here. It's a 5 thousandths resolution. There we go. And there we go, 2.05. That is going to put us 0.9 inches down from there. Next up is going to be our mix control, or our mix 2 control rather. Here is mix 2. And the distance between here and here is actually going to be 1.1 inches. So this guy needs to be at 0.95. So let's zoom in and see what we've got. That's 0.975. So we need to come down 25 thousandths. And this is going to make things interesting for us. I'll show you why here in just a second. So if we set our controls like this, then we've got to stick this switch such that it has a 0.9 inch delta there. So let's see if we can swing that here. See what this says. We know that this is 0.95, so this needs to be 0.05, which is not going to work with the height of our board. In fact, 0.95 and point. So this guy's going to need to come down. So that's where he would have to sit. So we're going to start by actually making our board just a little taller. And we're going to bump each of these guys up by 0.1 inch. Okay, so now we've got our controls on that side, and because this board is getting so long, we may actually want to come up and make a little space for our switch. It might be possible that we need to do that. So we're at, what did I say? This is 3.35, and if I were to, just doing some calculations here real quick. So if the height is 3.35 inches and we put that into our enclosure, we are, oh, you know, we'll be okay with our switch. It just means that our board is going to go pretty much right up to the top on the inside of our enclosure. So actually what I'm going to do here, oh, and you know, I got a little ahead of myself. So first I'm going to make a polygon on my bottom side. That's where I'm going to have all of my ground signal. We just go like this and like this. And what this will do is once we complete this polygon, it says, what do you want the signal to be? I'm going to tell it all of my grounds so that anything that goes to ground just simply has to punch through to that back layer. If we hit the rat's nest button, it shows us what our bottom layer looks like, and now our top layer. And I'm also going to miter these top corners so that they don't give us any issue with our with the inside of where the screws go on the inside of our enclosure. So we'll just do that. And you know, just to make things look nice, we'll do the same thing here. And we'll do the same thing here. Okay. Beautiful. And I'm going to just save this real quick so that we have that. And now we're going to put in our other controls. So now we've got all of our controls placed. These are the things that we are going to have to work around. So what I think I will go ahead and do, usually I place the chips first, but because this is a little complicated, I think what I'm going to do in general is I think my power is going to come in here. I'm going to do my power regulation and everything. I think I'll probably do one PT2399 over here and one kind of over here. Usually I like to have things very nicely laid out, have all my components put out very nicely in a very aesthetically pleasing fashion. With this weird control layout, that presents a little bit of an interesting challenge that I've not really had to do before. So we're on an adventure here. So now that we've got our controls placed, we're going to start roughly placing all of our components, including our solder pads, and you know, all of our chips, our resistors, our caps. We're mostly just looking to figure out if everything can fit the way that we've got it arranged right now, because if we determine that we can't fit everything the way it's arranged, we may need to revisit the control layout, or the footprint of the parts that we're using, or the size of the board, something. So as I'm going through, I'm putting things just kind of in an approximate manner. As we get into the part of the process where we start running traces, we will move parts around even more. But right now, I'm trying to keep things in their functional blocks. I'm referencing the schematic to try and make sure that I'm at least grouping the groups of components roughly where they need to be. But our final part placement is still going to change around quite a bit. Um, so, as we go through placing our parts, um, we need to not get totally hung up on all of the small details right now. We're just looking at the big details of, can everything fit? Where can certain things fit? Right now I'm going through and changing all of my resistors to be um, 1/8 watt instead of 1/4 watt because I need the extra space. That allows them to only take up as much space as a capacitor, so I can fit more parts on the board. And so I'm just continuing along trying to figure out where things can go so that I can fit everything in, because this is going to be a tight layout on this board. There are a lot of components here. One mistake that I did make with this is that I placed electrolytic capacitors above the time 1 pot, which is actually where one of the input jacks is going to go. And so when we get the actual board back, I'm going to have to lay those capacitors down so that they don't interfere with the jack. And it might be a big enough problem that we may need to actually end up um, spinning the board, doing another version of the board where I move those caps into the center so that I don't have anything interfering. So now we've got all of our components on the board. They all fit, they're roughly placed, which means that now we can start laying out the traces on the board. As we lay out the traces, I like to start with power. I use fatter traces for power because it's going to potentially draw more current. You can see that I'm now moving the caps around to be exactly where I want them to be for the purposes of having the traces line up where I want them to go, or minimizing the trace length. And as we go along, we may find that we need to run some traces on the bottom side of the board. I have the bottom side of the board set up as a ground plane. However, it's perfectly valid to use the bottom of the board for running signals. Um, just you need to make sure that you're not running so many signals that you don't have ground at the pads where you need ground to be. Um, you just want to make sure that, especially if you're going to have a lot of traces on the bottom, I like to try and make sure that they all kind of have a prevailing direction. So whether that be primarily up and down or primarily side to side, it helps kind of organize things, and it helps ensure that we're not going to run into an issue where we're trying to crisscross on the bottom of the board as well as the top. Now that I've got the power squared away, I'm going to use thinner traces. I'll go down to the LED and just kind of wire in the pot for the LED there, the little trimmer for the LED, and wire it to its pad to go to the switch. Mostly just to make sure that I get it out of the way. If I get it down first and run it right along the border, then I can keep it out of the way of everything else, and that way I don't have to worry about working around it later. And now I'm going to start working from the input. Because I have two different inputs, it makes things a little extra tricky. So I'm looping my input left trace around so that I'm not excluding any of the pads from those passive components from being able to reach um, the input R, which is what most of these first components are for. And as I'm going through this, I'm going to be moving things around. I'm going to be rotating them and shifting them, trying to figure out what's going to be the best placement. All these traces that I'm running right now, I don't have a high expectation that they're going to be the final traces. It's more just starting to feel out where the limits of the current placement are. And so don't be afraid to tear up your traces for a certain functional block and start shifting things around, because you may end up with something that is a lot better than what you had started with. If there are certain components that are giving you trouble, don't be afraid to just move them off the edge of the board and leave them for a little later as you get everything else kind of sorted out. Don't be afraid to move traces around and everything. But as you are routing the traces, just make sure that you're not cutting off paths from other parts as you're running the traces. For example, with the feedback pot right here, it's going to be important that we don't run a trace such that it's going to cut the feedback pot off from the components that we'll need to connect to it. So you'll actually see here in just a bit, as I run the trace from input R, I'm going to be very conscious of having it go underneath the pads for the feedback pot, because I don't want to box it out at all. So now that I've moved some of these components around, you can notice how my traces are much shorter. I have far fewer traces crisscrossing back and forth. There will be some long traces here and there, and that's fine. But as much as possible, you want to try and prevent paths from just crossing all over across the board, especially if you have anything like an LFO, or if it's a high gain circuit. You can start really running into noise issues there. And as I keep working my way up, something may look promising for a minute, but then as you get to a few more components down the road, it may end up not being as promising, because it forces you into some kind of a trace that either is impossible or that is really ugly. So this is really just a big puzzle, and it's a puzzle where you get to pick where the pieces go, but it is going to take some time. You can see that we haven't even made it through 10 passive components, and we've been working on this for a good few minutes now. However, don't shortchange yourself and try and rush through the process just to have something, because a good layout can really pay off in the end. And now that I've got these components here placed, we're going to really speed things up here for just a little bit. And I'm not going to show you the sped up version of everything. I'm actually just going to show you a little snippet here, because this whole process of running all of the traces takes a very long time, because not only are you moving parts, you're also moving traces, you're experimenting with the different layers. It's really at least for me, again, it's very much a trial and error type of an exercise. The next order of business that we're going to take care of is actually going to be deleting all of the component values from off the board. I like to delete the component values off the board because we may change component values later, and you don't want a wrong value silk screened onto the board forever and ever. I made that mistake with my first couple of boards, and it really messed me up when I went back later with some changed component values. So we're just going to use the delete button. We're going to zoom in, we're going to move around, and we're going to delete the component values. We're going to leave the component labels. Those will be important. But we want to try and clean up this board, having both the values and the labels on it really make it look rather cluttered. We'll just work our way through the board, getting rid of them so that we can then see what kind of space we have for our component labels and where we can place all of them. More than likely, some will slip through the cracks. That's okay. As we move the components or the component labels around, we'll find them and we'll get rid of them. And so now we're going to move the component labels around. You want to make sure that the component labels are placed either on their corresponding part or right next to it. You can see that little white line is showing where the label belongs. This is where using the, at least in Eagle, using the Alt key while moving things is really handy because it allows you to move things on a 5/1000ths of an inch grid instead of a 50/1000ths of an inch grid. And I just pick a place to start, it doesn't really matter, and work my way around. You'll see on this capacitor that the size of the label is actually larger than for my resistors. So I'm actually going to go through and I'm going to change the size of the capacitor labels so that it matches the size of the resistor labels. This will make things look more uniform. It will also save us a little bit of space so that we can pack our labels in there because we've got a lot of components on this board. It's very, very dense. If I was really smart, I would have just changed the part in my library so that the label size is the right size, but I've never gotten around to it. So instead I end up spending way more time than it takes to change the library, changing the labels. Maybe after this video I'll actually go and fix that. We'll have to see. I like to try and have some kind of order to the labels. With the resistors, I just put them on the part. With the capacitors, sometimes I do, sometimes I keep them off to the side. With this particular capacitor footprint, I can't really put the label in the footprint of the part, just because of the version of the part that I used. And that's okay, it's fine. This will all work out okay. Really just making sure that you are able to associate the label with the correct part is the most important thing here. We're also going to be moving around the labels for the different pads. You want to try and make it as intuitive as possible so that you're not having to constantly refer back to your layout files for what's what. When things get really tight, you have to start getting creative for where you place the labels. You may have to start placing them, you know, in whatever open bit of space you have that is close to the component, between pot lugs, underneath the ICs. Those are all places where you may have to put your labels if you don't have sufficient space. Again, the component placement is going to be a lot of trial and error. You may think that you've got everything placed really well, but then as you keep moving labels around or whatever, you find that it's not quite that simple. And then once we determine that all of our labels are placed where we want them and everything, um, we're going to create a text label for the top names, and that is going to give us our board name, the board revision, and I'm going to put a copyright notice on there just because, I mean, that's what I've had ingrained into me working in a technical field is you always copyright your stuff. Um, Probably not necessary, especially since I'm providing the files to the DIY community for free. Um, but that's what I'm gonna go ahead and do. Um, we're going to see that it doesn't all fit in the one spot that I thought maybe it would fit, so I'll break it up into two different pieces. I'll end up putting the name and rev of the board kind of right in the middle where it's highly visible. The copyright notice can go off to the side, it can hide in a corner or whatever. It's not a big deal where it goes. And then once we have that placed, our board will be ready to send off to fab. The last step is going to be doing the cam processor, which I actually did not get footage of in this screen capture, but I'm going to be using JLC PCB. They have a cam post processor file for Eagle, which makes it really easy to produce the Gerber files in the format that they use. And once we have those Gerber files, we are ready to go send the board off to fab. So we've got our board laid out, and now we can send it off to fab and we can see what mistakes we made, because usually the first revision of a board, while it may be really, really close to being perfect and having everything we want, sometimes there's something that kind of slips through the cracks. So I usually don't expect a 1.0 PCB to be the final thing. My alternate dimension design, I ended up going through 5 or 6 different revisions because it was really super sensitive to layout and placement of stuff. But there are other ones where the first version has worked just fine. So I've already placed an order for the board, should be here shortly, and then we'll get to build it up. When it comes in, we will assemble the board, we'll kind of tweak some of the values, and then we will do probably one of the most important things, which is test it before it ever goes in our enclosure. When I was learning to build earlier on, I would just put the circuit into the enclosure right away because I was so excited to hear it and everything, and then I wouldn't hear anything, and trying to troubleshoot inside of an enclosure is misery. As a sneak peek of what the pedal's going to look like, I decided that with the delay bouncing back and forth, it kind of reminded me of like an Old West showdown or something. So I decided to go with the name High Noon for the project. And so here's what my art looks like. It's got kind of that old Western theme. I'm thinking like some shotgun shell knobs, and I'm thinking like gold or kind of brass accents or copper accents somewhere, just to kind of play into that Old West theme. And so with that, it's just a waiting game until the boards come in. We'll catch you next time. Thanks for watching.